corporate finance practice problem using OneNote. We're going to have a scenario where we have a future value of an annuity calculation, but then in the middle of the annuity, we have a rate change making us adjust our plans at that point. Get ready. It's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if you would like to, we're in the tab on the left-hand side. We're in the practice problems and down in the number 955 future value of annuity interest rate tab. Also note that when using OneNote, you might want to take a look at the immersive reader, noting that many of our presentation files will be mirrored down here in the text type files with the same number. The text files, in essence, having a transcript. The transcript being able to translate in multiple different languages and either listened to or read in those languages, thereby being a good complement to the presentation files up top. Closing this back out with the icon on the left, we're going to have our information up top. We'll go through that information and work through the problem in the section down below. Like with prior problems, we will be doing most of the calculations from each section multiple different ways. If you would like to jump forward in the problem to see it just one way to move through the problem more quickly, feel free to jump forward in the presentation. So we have a scenario here where we have an annuity that's going to be set up. We have a situation where we want to get to $400,000. We have 15 years to get there. They're going to be semi-annual payments as opposed to annual payments, and the rate is going to be 10%. That's our original goal. Then once we set that up, once we figured that out, we had a problem that after 6 payments, we're saying that the rate's going to change to 12%, which messes up our whole annuity. So at that point in time, we need to then figure out where we stand after the 6 payments, which were at the 10%, and then think about what we're going to basically generate on those funds until the end of the 15 years, and then think about what we're going to have to set up for a new annuity, the annuity for the remainder of the time period, once again, to reach our goal of the 400,000. So we're going to start off with our starting point, one we've seen kind of in the past, so I'll do it a little bit more quickly to get to this 400,000. So we have this situation, starting point, where we have 400,000 we want to get to. We have 15 years to get there. We're assuming the rate of the 10%. We're going to have our equation, which is going to be the future value of an annuity. We're not solving for the annuity because we know what that is. That's the 400,000. We're looking for P, the payment. So it's going to be the 400,000. If we do this algebraically, 400,000 equals P, the unknown, times 1 plus R. R, be careful with R because it's semi-annual here, would be 10%, but it's semi-annual divided by 2, therefore 5%. To the power of n, number of periods. Once again, we got to be careful because it's semi-annual. 15 years then would be twice that because it's semi-annual 30 in terms of the periods, minus 1 divided by r, which once again would be 5%. So we could solve for it algebraically in that format, plugging it in, solving for it algebraically. I won't do the algebra here, but instead we'll do it in a table type of format. I'm not going to rework the presentation or the formula to solve for P in our table, but set up the table as a general formula solving for the future value of the annuity, and then think about how we then would possibly adjust this number up top in order to basically get to the bottom line number, which is a tool that we can use in Excel called GoalSeek. That then will lead us into the Excel tool that we can then use down here, which would be the future value of the annuity using a similar kind of function. And we'll also think about the payment function, which we haven't looked at so much in the past. That's another function that would get there a little bit more directly, but we're focusing in on the future value of the annuity function because that's kind of where our focus is. So let's do that. First, you could do it algebraically, and then second, we're going to put this formula into our table. The yellow item up here, this would be the unknown. So if this in practice, I would put a 1,000 here, something that we're taking a guess at, so that we can calculate this out and then adjust this yellow number until we get to the bottom line number that we think it should be, this number then reaching the 400,000. We'll then go to the numerator, which we're going to pull into the inside. So we got the 1 plus the rate. The rate's going to be 5%. Remember, we have the 10% up top, but it's semi-annual. So we take that 10% divided by 2, getting the 5%. The 1 and the 5% added together gives us the 105%. Then we take that to the number of periods, which once again we need to be careful of because it's 15 years, but semi-annual. Therefore, we have 6 months periods, so that's going to be 30. 30 periods. And then we're going to calculate this out. I'll pull out the trusty calculator because we do need a calculator that has the ability to go to the power of. I'm going to hit the hamburger on the calculator, scientific calculator, and I'll just recalculate. This is going to be 1 plus 0.05, and then to the power of 30, which is this icon down here, caret up top, 30. And that's going to give us our 4.32 and so on and so forth. We're then going to subtract out 1. So I'm going to say minus 1. That's going to give us our 3.232 and so on. That's going to be our entire numerator. Denominator then 5%. Again, that's the rate, which was the 10% divided by 2 because semi-annual. So I'll divide then by 0.05 or 5%. That's going to give us our 66.43 and so on. We can then multiply these two out. If I multiply that times the 6020.57, we then get to about the 400,000 giving rounding. I'm going to bring my normal standard calculator back in action. Now note that if this number up top was anything but the answer here, we'd have to back into it. If I put 1,000 here, for example, we'd have some number down here that would be something other than 400,000. And you can imagine us using trial and error then to climb up to the correct 6,020 piece by piece until we get to the proper end result, 400,000. Quite a tedious task with a calculator. With Excel, not a tedious task. We can use GoalSeek for it to do that for us. So we have the algebra we can do up top. We have the GoalSeek. We can also apply that concept for GoalSeek to use the standard future value formula. So if we plug this information into the standard future value formula, same concept, noting that the end result will be the future value, but we're looking for the payment. There's two ways you can look at this. You could say, I'd like to apply the algebra and solve for the payment, but I can't do that algebraically. There might be another function and is another function for payments. But if you don't know what that is, or you just want to use the function that you're familiar with, then you can solve for it if you have any one unknown using that similar GoalSeek feature. It would look like this. We got to be careful of the semi-annual components once again. So it's the future value rate is going to be the 10% divided by 2. So it's taking that 10% divided by 2, comma, number of periods would be the 15 times 2, taking that into consideration. And then we're taking comma, and then we're going to take the amount, which I would plug down here and guess what it is, 1,000, for example. Then the result would be something other than the answer, 400,000. We can then tell the system, we can say, hey, look, Excel, would you change this cell using GoalSeek to what it needs to be to make this function the proper end result, 400,000. That's one way we can do this if we want to use that future value formula. Another way we could do this and say, hey, look, it's a payment. I'm trying to solve for this thing right there. Is there another formula that Excel has that solves for that thing directly? There is. We can go to the payment formula. Would look something like this. The payment would be the rate, and that would be the 10% divided by 2, comma, the number of periods, once again, 15% times 2, comma, and then the amount, which is going to be what am I looking for? The future value. So we have to comma, because we use this for the present value and the future value. So we need to go to the future value, and that's going to be the 400. And that, once again, will give you that 6,020.57 that we match up here. So then we can also do this with the tables. We can do it with the tables here. So just remember, when you use the tables, we have to do the same thing. It's not 10% because it's semi-annual. It's 5% for the semi-annual per period, not 30, not 15, but 30. So 5% and 30 on the tables. 5%, 30 down here would then be the 66.439. So there's the 66.439. The yellow would be the unknown. The 400,000 would be known. Then to back into the amount, we would take the 400,000 divided by the amount from the table, 66.439. Might be slightly different due to the tables being rounded to 4 digits. Okay, so now the second component, then we're going to say, okay, that we set up the annuity, but now we have this situation where after 6 payments, the interest rate changed. So now I got to go, okay, now that messed up the whole thing. So now I got to figure out where we stand after those 6 payments. How much money do we have at the 10%? Then that lump sum amount, we could still generate revenue on it till the end. How much revenue will be generated from that? And then that future value minus the 400,000 is what we need to set up a new annuity for the remainder of the periods, which I believe is 24, which is 15 times 2, 30, minus the 6 periods that have passed. And we'll have to set up a new annuity to get to that 400,000. So let's first think about, okay, well, what must have happened for those 6 periods at the 10%? Where do we stand right now? And then future value it to the end of the 15 years or the full 30 periods. So we'll say, all right, we're gonna use the future value of an annuity, which is going to be the future value of annuity is P, which we know now, which is that 6,020 we figured out last time, times 1 plus R. R now is going to be 6 because this is 6 periods, which are semi-annual periods, to the N. R is going to be 12. R is going to be the 10% divided by 2, or 5. And then to the N, which is going to be the number of periods, which is 6, because this is given as the semi-annual periods, minus 1 divided by R, once again 5. Plugging that into our table over here, we put the P on the outside, 1 plus R to the N minus 1. So we're going to say 1 plus R, 5%, because we're still using this 10% divided by 2 because it's semi-annually. That gives us 105 to the period that has passed 6 periods. So 105 to the power of 6 gives us 1.340091 and so on. Minus 1 now, wrapping up the numerator, gives us 0.340096 and so on. The denominator, 5%. That is the rate. We take the numerator divided by the denominator. We get the 6.8019128 and so on. And then if we multiply this out, the 6020 times the 6.80 and so on, gives us the 40,941.42. So that's where we stand after those 6 payments. We got to get to the 400,000, but note that this end result is just after the 6 payments. I could still earn a return on it, and we're going to assume we're going to earn a return on that fixed amount for the 12 periods. So we're going to have to do a future value of 1 for it, and then figure out how much more we need to put in order to achieve the 400,000 after the remaining periods, or for the remaining periods, which are 24 periods left, I believe. But first, let's calculate this one a couple different ways before we go to the next component. We could do a running balance type of calculation. So if we had the 6021 for the period 1, and we multiplied times the rate, which is 5%, we would have a running balance looking something like this, 6021 about times the 0.05. That's the rate per period, so because it's semi-annual, gives us the 301. The 301 plus the 6021 payment for the second payment plus the 6021 in the prior period gives us 12,342 about. We take that times the 0.05 gives us the 617 plus the payment that goes in now, 6021, plus the prior balance we were at, 12342, gives us the 18,980, and so on and so forth. If we do that to the end, we get to that 40,951 again. If we scroll on down, we can also see this with the future value annuity. So this would be a future value of an annuity calculation, which would take into consider the rate, which would be the 10% divided by 2, or 5%, comma, number of periods, 6, because this is in semi-annual periods, comma, and then the payment, which we picked up was from the prior thing here, the 6021, and that would give us once again the 40,951.42. One more time with the tables, the 6020.57. Then from the tables, we're taking 10 divided by 2, 5% for 6 periods. 5%, 6 periods, 6.8019. So 6020.57 times 6.8019, 40,951.34. Close but not exact to what we had up top due to rounding, the table rounding to 4 digits. So now that we know this number, I need to future value that. I need to have a future value of 1, assuming that we're going to return 12% on that for the remaining periods. and that's going to be, it was 30 periods, semi-annual, 15 times 2 minus the 6 periods that passed. Now 24 periods remain. Once I do that, then I can figure out how much more needs to go in to get to that 400,000. So we're going to need to present value this amount we got to. So we're going to say, all right, we're going to future value it. Future value that amount. So we're going to say, now our future value calculation is going to be future value equals the present value times 1 plus r to the n. So the present value is the thing we just calculated up top times 1 plus r. We're going to assume now r being the 12%. So 12% is that semi-annual, I believe, divided by 2, which would be 6%, I believe, because it's semi-annual, to the number of n, which is now the periods that remain. We had 30, 15 times 2, minus 6, which is going to be 24. We'll put this into our table down below in our table format. So there's our 40,951 that we got to last time. Then we're going to say we have 1 plus r, which is 6%. 6% now saying that 12 divided by 2, that was the change. We think we're going to earn 12% on it now. Future value of 1, that's 601. And then we're going to take it to 24 time periods because we had 30 before. 15 times 2 minus the 6, 24 remaining. So 106% to the power of 24 gives us 4.048936 and so on. Multiplying these two out, then final result 165,809.62. So that means after this point in time, we're going to future value. By the time we get to the end of this 15 years, we think we're going to have that amount. We need to get to the 400,000 minus what we have, our future value that we think at this point, 165,809.62, means we're going to need another 234,190.38. So we're going to have to figure out another annuity for the remaining time period that will get to that number. We'll do that next time, but first we're going to go through this calculation in multiple different ways. So if you want to skip forward to the next one, you can, but we'll do the running balance here. Running balance, we're going to say it starts at the 40,951, and then we'll multiply this out. So we have 40,951 times 0.06. That's the 2457 plus the prior balance 40951. That gives us the 43,409. If we take that times the 0.06, we get the 22605 about, plus the prior balance 43409. Gives us the 4613 and so on. We can do this on down, and that would get us to, at the end of the day, the 165,810 about. We took the pennies off this time. Scrolling back down, we can also do that, of course, with the Excel function, which would probably be the most common use here. So look, this one looks a bit confusing, but let's just see if we can break this out. We have the rate. The rate is going to be the 12% divided by 2. So we divided that by 2. Comma, the number of periods is the one that's confusing, right? We calculated the number of periods as this number up top is the 15 times 2. That's why we multiplied it times 2 down here, which gets us, of course, to the 30. And then we took minus this cell, which is 6, minus 6. That would give us to the 24, comma, comma. And then the present value, which is a point we got to last time, 4951 about. That once again gets us to the 165,809.62. Let's do it with the tables now. Now we got the 40,951.40 on the tables. We're looking for 6% and 6% and the 24 period. So we're looking 6%, 24, which is way down here. That's 4.0489. 4.0489. So if we take the 40951.4 times the 4.0489, that gives us the 165,808.20 about. And then that's a little bit different possibly than what we got up top here, and that's due to the rounding. So now we're going to take this amount and do the last part. We want to get to the 400,000. We think that at this point, future value at the end of the 15 years will be 165,809 based on what we have thus far. Therefore, we need another annuity for the remainder of the time periods, 24 periods, that will get us up to that number, 234,190.38. So let's do that a couple different ways. It's a similar calculation than we started with because this is similar to our original goal. where we wanted to get to the 400,000 in 15 periods at the 10%, looking for the payment. Now we just have a different set of numbers, same kind of problem. We have the future value, which now is going to be this number, the 234,190.38 equals P, the unknown, times 1 plus R now being 12% annually, but semi-annually, 12% divided by 2, to then the number of periods, which was 30, but now it's 15 times 2, 30, minus the 6, or 24 periods, minus 1, divided by R, once again, 6%. I'll let you do that algebra if you want to do it algebraically. We'll do it down here with our table, putting this same thing into the table, not solving for it for P, not adjusting our table for P, but as if we're setting up the table to solve for the future value, so that we can then think about how we would adjust this top number in a trial and error fashion, which can be done easily using Excel, using GoalSeek, and then we'll look at that concept as we use the function. So we can imagine this yellow number being in there at like 1,000 or something like that. This is actually the answer, but we could put like 1,000 there. Then we'd have 1 plus the 6%, 1 plus the rate gives us 106 to the power of 24 number of periods would give us 4.048931. And then we're going to subtract out the 1 to give us the end of the numerator, 3.04 and so on. Divided by the rate, once again, 12 divided by 2, or 6, would give us this 50.815577. Then we can multiply out the 460666 and this number to get to the end result, the 234,191.80 about. Now note, again, if this number was something other than 4608, maybe it was 1,000, we can then imagine trial and error, making it 2,000, making it 3,000, until the end result gets to the point we want. That would be tedious to do with a calculator, easy to do with Excel. We can use GoalSeek to do that. We can use that same concept if we know the functions in Excel. For example, if I know the function for the future value of an annuity, even though I'm looking for a payment, which is part of the function, I can still use that same function using that concept and then using GoalSeek. Or I can look in Excel for another function, which would solve directly for the payment, which there is one there as well. So just keep in mind that you can use a function to kind of back into the number. You could probably find another function in Excel as well, but just keep those two things in mind as you work through it. We're working with the future value, so we'll use this concept first, and then we'll take a look at the payment method. So the future value would be then the rate, which would be 12% divided by 2. So we took this cell divided by 2, comma, number of periods. This is the one that's a little confusing. It would be the 15. It'd be 15 times 2 minus 6, or 24. That's what we did here, 15 times 2 minus 6, 24, comma. And then we picked up the payment, which we said was down here, guessing what the payment was. If we start off with, say, 1,000, then we can use GoalSeek to say, hey, look, I would like to set Excel, please make the end result number be this number by changing that cell, and it will then use trial and error in order to do that very quickly and pick up the proper number. Or you could say, hey, I'm really trying to solve for this payment item here. Is there a payment formula? There is. We could set up the payment formula, which would be the rate, which would be the 12% divided by 2, comma, number of periods, same thing, 24, which was the 15 times 2 minus the 6, comma, comma, future value then being the amount of the 234,191.80, and that would then give us our same result here. So there we have that. Let's do it just with the tables then. With the tables, we'd have 6%. We're looking 6% and 24 periods, right? 6% and 24 periods. 6 and then down on to the 24 gives us the 50.816. The 50.816. And then we're going to back into the amount up top. So it would be something like the 234,191.8 divided by the 50.816 is going to give us that 4608.62, which is close to, may not be exact to what we got before, which was the 4608.66 due to the difference of the rounding tables going out to the 4 digits. So basically, this is the new annuity that we would have to be putting in place for that 24 time periods once again to add to what we have thus far after we future value it in order to get to that $400,000 after the adjustment of the rate change from the 10% to the 12% after 6 payments.